Bismillah ar-Rahman ar-Rahim. So we started to talk about chapter 6 last time. So we talked about the basic functionality for the network layer, in addition to the two basic functions for any layer, which is encapsulation and decapsulation. We also talked about routing and addressing as basic functions for the network layer. We also covered the characteristics of the network layer, including the connection list, the fact that we don't have to inform the receiving router that we are sending any packets, which also leads to the fact that the communication is not reliable end to end, and in that case, network layer provides best effort service in the sense that it does not guarantee the delivery of the packet, and we'll talk about some scenarios today where this actually happens. And the third characteristic, of course, which is medium independence. So today we'll talk about the protocol data unit for the network layer, and we'll talk about IP version 4 later. Inshallah, we'll talk about the format of IP version 6 and the difference between them. So IP version 4 is the predominant protocol for the network layer and the most common protocol on the internet when it comes to network layer. Unlike other layers where we have many standards, like for the case of data link layer, we have Ethernet, we have Wi-Fi, and so on. For the transport layer, we also have TCP and UDP. For network layer, we don't have anything other than IP. And IP has two versions, version 4 and version 6. So today we'll cover IP version 4. So this is the protocol header for IP, and of course here we have, of course, the implicitly we have the data part, which includes the transport protocol data unit, including the transport layer header and the actual data from the application. So the header itself for IP includes so we need to match the empty spaces with the boxes here. So the first one is what? First one is what? Anyone can answer. So the first field here is what? Just to make it bidirectionally. Badr Muhammad, do you know? Badr Muhannad, do you know? Badr. You don't know. Okay, fair enough. Okay. Anyone knows? Abdullah Khalili, do you know? What is the first field here? Huh? Version, yeah. The first field here is version. Okay. So you save the rest of the class. And then this is what we call internet header length. Okay. And then there is the differentiated service field, differentiated services field. Okay. And then we have the total length. Okay. Then the second row, we have the second row is actually used for a very important functionality, which is fragmentation. We hinted about fragmentation last time, if you remember. So the first thing is the identifier, okay, or identification, and then the flag, and then the fragment offset. Okay. The third row, we have what we call time to live, or TTL. Okay. And then we have what? The protocol. Bravo. Okay. صح كده. Okay. And then we have the checksum. Okay. Then we have two rows one is the source address, which takes 4 bytes, and one is the destination address. Okay. There's no, I mean, this row is actually, it's not just one row. As we can see here, the header is actually organized in a row, in rows كده, and each row is actually 4 bytes, which means that these 5 rows that we have talked about so far, they constitute, or they represent 20 bytes altogether. 20 bytes is the minimum header length for the IP header. This is the minimum, 20 bytes, okay? But in fact, the IP header can get from minimum of 20 all the way to 60 bytes, okay? So we'll talk about this. Type. First, let's take them one by one. And actually, before we get to that, we have here two fields which we will talk about, which are not actually mentioned here in the boxes. We have the options field, and we have the padding. There are no boxes here for options and padding, but we will talk about them. Okay, so let's take them one by one. The version field is how many bits? It's 4 bits. Okay, so it's half a byte or 4 bits. This is 1 byte, and this is 1 byte, and so on. So each row is actually 4 bytes or 32 bits. So the version field is actually 4 bytes. Okay, so 4 bytes, which can take any value from 4 zeros all the way to 4 ones. But here the version, it has only 2 choices. So either IP version 4, so the version field would have, for IP version 4, it would have 4, which is 0100. Okay, for IP version 6, so this is 4. For IP version 6, it would be what? 0110. Okay, so that's easy. So if you see the version contains the value of 4, this means that the header is in IP version 4 format. If the version field is 0110, this means that it's 6, which means that the header format follows the IP version 6 header format. Okay. طيب, the internet, the IHL here is 4 bits only, okay? And it contains the header length from the name. It's internet header length. So it contains the header length. But the header length, as we said, is from 20 bytes all the way to 60 bytes, because this options field might get up to 40 bytes. Okay, so now what can we do, or what the protocol developers could do or should do, or they did already, to represent the length from 20 all the way to 60 bytes using only 4 bytes? Okay, how can we do this? How can we do this? Any raise of hand? That's a bonus question. No raise of hand? No one watched the videos? Okay. So the way that we do this is that each number in the IHL represents the number of 4-byte words, which means that the maximum number that these 4 bytes can have is 4 ones. 4 ones indicate 15. So if we multiply 15 by 4, okay, which is the number of rows, or the number of 4-byte words, 4 times 15, okay, is 60, which is the maximum number of bytes that the header could actually have. And the minimum the minimum number for the internet header length is in fact 0101, which indicates 5. So 5 times 4 is 20. So the way that we represent the length for the 60 bytes header or 60 byte header using only 4 bytes is by representing the number of 4 byte words. Okay, type. Differentiated services. Yes. If you answer your own question, I will give you a bonus. This is a good question, by the way. This is a very good question. That the length of the header, it has to be multiples of 4. Okay? So what if the header is not multiples of 4? Like, for example, the header is actually 30 bytes. What do we do? Any guess? This is actually. Go ahead. This is exactly what this padding is for. Okay, as we said before, padding is like the foam that you put in the package. When you receive a package from Amazon and you see like some foam around the item, it's just to align the item because the item is a little bit smaller than the box. Okay, so we put some foam around it to align the item and make it stable, right? So that's exactly what happens. So this padding is actually dummy bits. We don't actually use it in any way, but we just put any dummy bits here to indicate that the length has to be in multiples of 4. Okay, and these dummy bits are all zeros, which they represent nothing. So once we read the header, we throw them away. We don't actually have to use them in any way. Okay, واضح كده? So that's actually a good question. So the next field here is differentiated services. Differentiated services, as we have discussed in chapter 1, actually, differentiated services is about trying to maintain some discrimination between the different types of traffic. And discrimination here is done in a good sense, in the sense that video will take higher priority than audio, than text, and so on. So this way, the quality of the service will be better. If we give higher priority for video, especially if you're watching a movie or you watch any video on YouTube and stuff like that, you won't end up with some pauses and some discrepancies or some impairments in the video that would give you very bad impression about the service. Instead, what we do is that we give the video higher priority and than someone who's actually browsing the internet with no interactivity, with no frequent interaction. So this way we can optimize the quality of service for the different users based on the type of traffic they use. So this differentiated service field is used exactly for that. And as we can see here, it's 1 byte, which is actually divided into 2 fields actually. The first one is 6 bits, and it's called differentiated service code point. This is the differentiated service code point field, which indicates the priority of the packet. So 6 bits, which means that we have up to 2 to the power 6 different types of priorities that we can give for the different types of traffic. So for example, we can give video 6 ones, which means the video has the highest priority. We can give the text all zeros to indicate that this is the lowest priority, and any traffic in between, we can give them any number in between those 2 priorities. Okay, so there are 2 bits here which we call them explicit congestion notification. This is this one. So the differentiated service code point and the explicit congestion notification. Explicit congestion notification indicates whether or not the router or the network layer is in the state of congestion. What does that mean? This means that if as we said before, the router, okay, it's like an intersection or a roundabout, which is actually used to route, to do packet forwarding from one input port to one output port. So we can imagine that this router is like a roundabout or an intersection, which has some cars that represent the packets that are coming from different directions, and these cars, they want to go to different directions, right? So if we have these packets coming to the router, okay, in a very, very high rate, okay, what happens is that the router will actually try to process each packet and send it to one output port, which is what we called packet forwarding. So the router will have to consult a routing table. We'll talk about this next time. We'll have to consult a routing table to perform routing for this packet based on the destination IP address, right? So this process itself takes time. The packet forwarding takes time. So imagine if you have, too many cars are coming to the intersection, and more than what the intersection can handle. So in that case, we will be in a state of congestion or traffic jam. Okay, so congestion is like traffic jam in real life. So if the router is in the state of congestion, then the router may in fact send explicit congestion notification back to the source. And what this field does is exactly similar to the fact that I'm telling the source, please try to slow down because I cannot cope with the traffic that is coming from the internet. Okay, the use of this field, by the way, this is very important, Bayani. The use of these two fields, by the way, is defined in the standard, but it's left to the vendor to implement in any way they see appropriate. For example, explicit congestion notification, there is no mandate that you have to send explicit congestion notification back to the source. It's optional. And the differentiated service code point, they define 6 bits, but they don't actually define any details. They don't say that you have to use this for video, this for audio. They leave it up to the vendor who implements the standard on the router to use these fields, in any way they see appropriate. Okay, so this is important to keep in mind. But in any way, they define the high-level functionality. So explicit congestion notification is used by the router so that it may actually send explicit congestion notification back to the source. So this is equivalent to, from real life, برضو, if you want to really give some example from real life. So imagine if you are getting into طريق الشمال or any highway, and the highway is jammed. The highway is, has a lot of traffic. So this is exactly equivalent to like a policeman standing at the entrance, at some of the entrances of the highway, and he would regulate the traffic by saying, all the trucks, they cannot go to the highway at this point. These cars should go this way. These cars should go this way, so that they try to regulate the traffic getting into the highway. Why? Because the highway is in the state of congestion or a state of traffic jam. So that's exactly what the router tries to do, or may try to do, by sending explicit congestion notification back to the source. All right, so as we said, we have the internet header length, because of the fact that we have variable length. As we said, the header can get from 20 to 60, right? So that's why we have internet header length. But we also have total length. And this total length is in fact the length of the data and the header. Okay, so if the header itself is 20 bytes and we have a data of 1500 bytes, let's say, so this total length should have 1520, okay, to indicate the length of the data and the length of the header. And of course, we have a total length because of the fact that the data part is also variable. So, for example, Ethernet has a maximum size of 1500. Wi-Fi has a maximum size maybe less than 1500, maybe 500 or something. So this data part is also has variable size. So this field is 16 bits, right? Okay. So what is the maximum theoretical length of the IP version 4 protocol data unit? What is the maximum size? What is the maximum size here? Mahinullah, do you know? Plus 60? Why? No, as I said, this total length is actually the total length of the header plus the data. So it's what you're saying is right. It's 2 to the power 16. Okay, of course minus 1 because actually we start from 0. So the total length is actually 2 to the power 16 minus 1. Okay, which includes the header plus the data. But of course, we can almost never get to that maximum length because of the fact that we also have a limiting factor from the data link layer, which is the maximum transmission unit. And as we know, Ethernet, for example, uses 1500. Okay, so 2 to the power 16, by the way, is like 65,000 something. So we can almost never get to that. So we can typically get to 1500, 2000, something like this, depending on the medium or the network access standards that we're talking about. Okay, which we will talk about next time. Actually, the use of how to use this row, which is the identification flag and fragment offset. As we said before, we use it for fragmentation. Fragmentation is a process that the router does when it receives on an input port, which is like, for example, uses Ethernet with like 1500 bytes. It receives a packet and it needs to send on the other side, on the output port, and the output port happens to be like, for example, let's say wireless, and wireless has 500 as a maximum transmission unit. So in that case, the 1500 has to be divided into 3 different fragments. We call it fragments. So these fields are used to facilitate the fragmentation process, which we will talk about in details, inshallah. Okay, type. So in the next row here, there is the field TTL. How is the TTL used? What does it stand for, TTL, and how it's used? The interaction is very low today. Hussam Yahya, do you know? Okay. Faisal, do you know? The question is, what is this TTL used for? What does it stand for and what it's used for? فجاسم بيقول لك الميد term. Okay, so hopefully this lack of interaction is because of the fact that you are studying for the midterm. So I expect the midterm to be perfect then. All right, so TTL here stands for time to live. Time to live. So the time to live here indicates the time that this packet can live inside the internet. Okay, the maximum time that this packet can live on the internet. But in fact, we cannot just use time, because if we use time, let's say مثلا we say that the maximum time that this packet can live on the internet is 2 minutes. 2 minutes with respect to what? With respect to which clock? Because we have too many routers and they use different clocks, they use different time zones, they use different things. So we cannot actually use a time reference easily on the internet. So that's why this is in fact part of the imperfections of the protocol developers. At the beginning, they said, okay, so let's just indicate the time that this packet can live. And later on, they found that using the time is actually very difficult. So instead, they made it very simple. They said that, okay, so the time we will not actually use time to indicate the life of the packet on the internet. We will start this with a specific count, maximum count. Okay, so when a router receives the packet, that the TTL will start, let's say, from 255. Okay, which is the 1 byte, so it's 255. So this router will say, okay, so I will send it to the output port, but I will decrement this by 1, so the TTL becomes 254. Okay, so each router receives the packet and performs routing, it has to decrement this by 1. So every time you decrement it by 1. So if it goes to a router and the router finds this TTL equals to 0, then this means that this packet has passed through 256 routers without reaching the final destination. So that's an indication that this packet is going into loops. Remember, we talked about looping when we said that, you know, we get out of our houses wanting to go to QU, for example, and then we go through the usual commute or the usual route that we used to go to QU, and all of a sudden we see some interaction, construction. So we have to do a detour, and we go into a detour. Then we may actually go to the beginning of the route again. So we have to repeat, and we go into loops. And in fact, even Google Maps and Waze, and they actually sometimes fall into that trap, giving you like a loop based route. So it asks you to go back to the same point again. So this packet looping may in fact happen on the internet, and the way that we mitigate or we try to avoid this is by using the time to live. Okay, so if this time to live is decremented all the way to 0, then this router will discard the packet, and it's fine, because, you know, when we discard the packet, by the way, we don't have to do anything. Why? Because again, network layer is best effort, so I don't have any guarantees. So if the packet is looping on the internet, which might actually happen, I will drop the packet. That's it. So I don't have to do anything else because we're best effort. I said that I will do my best, but there is no guarantee that this packet will be delivered. ماشي كده? Any questions so far? The protocol field indicates the protocol in the upper layer. What are the possible protocols in the upper layer? What are the possible protocols in the upper layer? What is the upper layer أصلا? What is the upper layer أصلا? Hussam, what is the upper layer? What? Sorry, I didn't hear. After the network layer, we have the application? لا لا لا, the layer above. Transport layer. The transport layer. So what are the possible protocols in the transport layer? We will study them. We have TCP, we have UDP, things like that. So this protocol field indicates the protocol in the upper layer. What was the field? And this is a question based on your studies for midterm. And if you are really studying for the midterm, what is the field that corresponds to this protocol field in the data link layer or in Ethernet? What was the name of that field? Jasim, مش انت بتقول we're studying for the midterm? What was the name of the field in the data link layer that corresponds to the protocol? Yasim. Yes, what was the name of the field in the data link layer that indicates the protocol? Yes, Badr. The frame A? Yeah, in the frame, yes, in the frame format, yes. The type, yes, the type. So the type indicates the protocol in the upper layer, which might be IP version 4, IP version 6, or something like this. We also have here the protocol to indicate the protocol or the standard in the upper layer, which is in the transport layer, which could be TCP, UDP, things like that. ماشي كده؟ طيب. The checksum here is 16 bits, which is used for error detection, Checksum is always used for error detection. So the way that this works is simply the router will get the header and the data part and will put it in 16 bits aligned like this, which means that each 4 byte word will take two 16 bits here. So this is one row and this is one row and so on. So it will organize or arrange the header and the data, okay, in 16-bit words, and then it will add or XOR all the bits in each column, and then it will put this in the checksum. Okay, so when it goes to another router, this router will have to do the same process, and then it checks if the checksum matches. Then most probably there is no problem with the packet, so it can perform the routing and it can perform all the functionality. If the value of the checksum is not matching, so this indicates that there is an error in the packet. So again, I discard the packet without having to do anything, because again, we are best effort. We are unreliable. Okay, so that's how we use the checksum type. The source address the source address is the address of the source, but the IP address, of course, the IP address is 4 bytes, which means that it's 4 values, and we will talk about the dotted decimal format for the IP, which we all use on a daily basis. So you have 192.168 and so on. So we'll talk about it in the next 2 chapters in great details, and we'll be able to calculate each of these bytes and so on when we will perform some functionality or some calculations on these IP addresses. So the destination address is the same, and as you can see here, we have source address and then destination address, whereas in the data link layer we have destination address first and then the source address. So here, as I said before, because of the fact that the MAC sublayer in the data link layer is done in hardware, we need to put the destination address first, because that's what we need to read first. This is what the switch needs to read in order to perform its functionality. But here, once we go to the upper layers are done in software, which means that the protocol data unit in the upper layers is actually a data structure which is software. So we can read any part of this data structure at any point of time using pointers. If you study C وكده, so we can access the source address, we can access destination, we can access identification at any point of time. So we can have any access to any of these fields at any point of time. Okay, so we don't have to go sequential, which is the case for hardware. Okay, type. So type the options field also, it indicates the imperfection of the protocol development, or the development of the IP version 4, because the options fields here indicates just a placeholder for any future functionality of IP. And the standard developers, they have identified, or they have included these options fields in the standard just to account for any future extension to IP version 4. And they said that this field could be up to 40 bytes, but the definition of this field depends on some future functionality which will happen in the future. Later on, they found out that IP version 6, we have to change the protocol header altogether. So this options fields in IP version 4 is almost never used. Almost never used. And in fact, in IP version 6, we removed it. And we'll talk about many fields that in IP version 6 we tried to remove, given the lessons learned from the development of IP version 4 standards. Okay, so we'll talk about this, inshallah. All right, so any questions so far? So we took a long time to discuss, and I always like to really criticize and comprehend about why do we have this field here? Why do we have the length of this field like this? What is this field used for? What is this field not used for? And so on. ماشي كده? So given that actually the next two activities are very straightforward. So I'll give you 1 minute to think about this, and then we can try to solve it together. Yeah. Okay. So I'll give you 1 minute to just think about it, and we'll try to solve it together. So which of these fields identifies the priority of the packet? Differentiated services, right? Particularly differentiated service code point, which is part of the differentiated service. Okay. So always set to 0100 for IP version 4. That's all I gave you. So what is this? Version. Yes. Okay. So this is the same person, right? Okay. Okay. So identifies the upper layer protocol. What is this? Protocol. So okay. Okay. So commonly referred to as hop count. What is this? Time to live. Right. Identifies the IP address of the recipient. So this is destination, of course. Right? Identifies the IP address of the source. So this is a source address. Maximum value is 65,000. The total length. The total length. This is key sure. Okay. Yeah. You saved the other classmates. Okay. So as we talk about again the same thing. So this is part 2 of that same activity. I will also give you 1 minute to think about this, and then we'll solve it together. Type, okay, which field is decremented at each router, and if 0, router will drop the packet? The TTL. Okay. Which field is used to send congestion notification? Differentiated services, right? And it's actually it's not the whole field. It's actually the part of it, which is the explicit congestion notification. As we said, differentiated service code point and the explicit congestion notification, both they represent or they constitute the differentiated service. Then identifies the number of 32-bit words in the header. No. IHL. Okay. Refers to the size of the header and the transport layer segment. Total length, right? The total length. Receiving router will match this field with the summation of all words in the packet. That checksum, right? Is set to 5 for minimum and 15 for maximum header length. واضح ده طبعا. IHL. And the error checks the IP header. If incorrect, the packet is discarded. This is a checksum. Okay, so again, we have two definitions of the same field, or for the same field, to indicate that we can have multiple ways that we can represent the function of the same field. Okay. Any questions? So next time, inshallah, we'll start to talk about the fragmentation process in details.